So two things to mention already on the title slide. So one is there's a second name on here, Todor Boev. Some of you might know him. He's a colleague of mine, so we are both architects at SoftwareAG, and he's also a long-time contributor to the expert groups, and he's unfortunately not able to be here today, but he's very much present sort of in both the thinking and the code that I'm perhaps going to show. Other remark is you're seeing OSGi with an uppercase I. That's of course not the correct spelling. That's how our PowerPoint templates work. So I apologize for that. Okay, so this talk is about Java modules and OSGi. So a big topic, hopefully. Apparently you're not saying, okay, not again, talk about Java modules. But it's been a long and winding journey for modularity to arrive in the Java platform. So now it's here. This talk is not so much about how OSGi is positioned relative to the Java modularity concepts. I think that position has been made clear. This is sort of taking the position that we accept that Java modules are part of the runtime that OSGi is dependent on, and how can they coexist. And this is, again, I would like to repeat, this is from discussions in the expert groups. So now that release 7 is out, we're of course already working on release 8 of the OSGi specs, and this is sort of what we think is a candidate spec for R8. So to look at the most simple example that you can think of, you have a bundle that requires something from the Java platform, like AWT for some reason. So OSGi has traditionally shielded you quite well from the Java platform. You could inquire which Java packages are available from the platform, but that's more or less it. Now that the JRE consists of, well, between 60 and 80 different modules, it can be interesting to know which modules do you actually depend on. And this is what this work is about, what the RFP is about. So our proposal is to have a proper way of encoding the information about Java modules as resources in OSGi speak. So an RFP is a request for a specification. So what we're doing here, we're requesting that OSGi create a specification to address this, and the talk is presenting the requirements of this. We're following more or less the structure of the RFP document that you can find, which is giving the problem statement and identifying some use cases, but then listing the requirements that a solution should fulfill. So which requirements do we think should apply to this specification that we're asking for? And additionally, I want to show why this all makes sense in a proof of concept, which is a proposal how the solution could look, and also some code to make it hopefully more clear how this could actually look at runtime. So the problem statement is we want Java applications using OSGi with minimal footprint, and with OSGi we know quite well how to build the set of required bundles. So we have a very good way of expressing dependencies, of resolving them, of getting configurations that are valid at runtime. But this solves a part of our problem, because the JRE can be even the major factor of the overall size of the application that we're going to get in the end. Now, since Java 9, JRE has been decomposed into modules, and we can strip down the JRE that we're using to the modules that we require. So we can use JLink to build the runtime and have our application run with it. Thing is, how do we determine which ones we need? And with R7, at least, we get the actual list of packages that the boot layer provides us. It could differ depending on your on the Java version that you're using or the Java vendor that you're relying on. So R9, I think, had around 80 modules, and Java 10 that I last looked at had about 60. So modules come, but mostly they go because Java is using this new capability to actually throw out some stuff they think shouldn't belong to the core. And so if you want to try to find out which modules you actually need from the boot layer, you are usually subject to a trial and error process. So our proposal is to make the modules as such as they are defined by Java visible to the tools, to the OSGi tools, and to the OSGi runtime. So I don't know who of you would actually know offhand which modules AWT requires to run, which of the 60 ones that I have in my environment here. Anybody know? I don't either. I'll know again when I look at the happy end, hopefully when I run the code. Okay, so these are the use cases that we define in the RFP. Yes, sure, go ahead. Yes, yes. Mm-hmm. So one use case is to build a compact Docker image. So we want to run our applications in containers. We want to perhaps replicate the containers, have many of them, so footprint is important. We have this situation where we want to have a tool which requires no installation, which just you drop onto the disk and unpack it and run it. Again, you want minimal footprint. Sometimes you just want to know, you want to be able to find out which parts of my OSGi application are contributing to the footprint in which way, so you want to be able to analyze. There might even be runtime scenarios where you want to, at runtime, be able to reason about which modules your bundles are using to have some, make some runtime decisions on that. And perhaps also it could be attractive to be able to build applications combining the two modularity approaches, so the static Java one with the dynamic and much more powerful OSGi one, but still have the whole process of configuring the runtime be homogeneous. So the proposal again is to model Java modules as OSGi resources. So for those who are not so deep into this, so anything in the OSGi runtime, or most things, can be viewed as OSGi resources, and OSGi resources at their core provide capabilities and have requirements. So the most well-known one is a bundle that has the capability of providing packages and having requirements like requiring other packages to be present, or depending on a certain runtime version, or even more abstract capabilities. So the most well-known ones are from the textual manifests, but the requirement capability concept in OSGi is very generic. So you can describe lots of things there. And the requirement that we want to state for this specification is that regardless of what kind of approach we come up with, we should still be using the resolver to compute the consistent set of modules and bundles that we have at runtime. So we do not want to introduce the need for an additional component or something new in the tool chain, because we think the resolver is exactly the right component to handle dependencies, and it does a good job at that. And it's a well-known and piece of the OSGi architecture. We also would not want to introduce the need for bundles to reference modules directly. So kind of defeats the purpose if we would say our bundle requiring AWT now has to specify a requirement on the module that provides AWT. That doesn't make much sense. We could allow bundles to reference modules if there is some reason for it, so it doesn't preclude that. bundles can function as modules. We shouldn't prevent that from happening. So there could be cases that you actually have something that is technically an OSGi bundle, but for some reason you put it on the module class path of your Java runtime. That should be allowed. And the OSGi framework itself is a special case, which you might throw on the module class path, and from there it does its OSGi magic. And as you mentioned, third-party modules should be covered also. Also, we would want the mechanism to allow doing those validations that JPMS defines, like we can't have two modules that export the same package, or modules can't have cyclic dependencies. Yeah, I think that would be, well, we can't have duplicate modules, yeah. So we can't have two modules of different versions. The whole version concept is a quite weak thing in JPMS. So these would be the general requirements, and more specifically about the resolving itself. So we want to be able to represent modules with their identity and their version, which is mainly the name and the version if there is if one is given. We want to resolve the bundle package imports to module exports. That's one of the main features of this. So if a bundle requires something, it should be wired up to a module export, if that's the provider of choice. We want to include modules depending on other modules, which is one core aspect of the Java module system. And what we've stated as optional would be handling services as well, in the Java sense, where you have the service loader API to define services in Java. And there's even the service loader mediator in the OSGi to make it very easy to interact with these. So these would ideally be covered as well. We could do more. So we could even try to add version ranges to modules. So we could add metadata to the modules that Java doesn't itself provide. So some cases you can determine against which other modules a module was built. So you could encode that also in the in our OSGi specific resource modeling for Java modules by deriving a version range from that. Yes? Yeah?
Maybe this is a lack of knowledge, but my knowledge is that Java modules don't have a version.
Well, they do have a version attribute, but it's not required. So in many cases, it would just be empty. There is a version object, and it even has some semantics for comparing versions, but there's no semantics attached to Java module itself and to the JPMS. So there's no required processing, and there's no protection against using one version or the other. And there's even if you put two modules on the module path, it will simply be an error. And Java will not be able to choose one or the other based on version, for example. Yeah. But here we could include that in the modeling concept if we wanted, and even derive it for tools and add it, because the resolver is so strong about this. Okay, we could, to add this extra metadata, we could use bundle annotations. So remember BJ clamoring for more annotations, more annotations, more annotations. This would be a nice extra boon for using annotations. And as already mentioned, we could do more with these. No, sorry, the last point is there is a way to ask OSGi, the root bundle, for all the Java packages, but our proposal is to replace this so that this would actually return an empty list, the system package, and you would ask for the model resources and query for the Java system packages directly by inspecting the module resources. So that wraps up the RFP more or less, because I've mentioned all the requirements and the basic idea. And to make this more valid as a proposal, we've created a proof of concept showing how could such a modeling actually look. And our proposal would be, that would already be the specification, would be, let's model a module as a special kind of bundle. So let's reuse the bundle concept, but have it as a special kind of bundle. So we would not be introducing new a new namespace or new types of first-class objects. We would just be saying modules are special kinds of bundles, and we would be using the require bundle way of modeling the dependencies between Java modules. And module exports would just become normal export packages in the well-known OSGi way. And we would provide the service loader services also as capabilities and as requirements. So this is a more advanced aspect of this. So this would be our approach. I'll show a little more detail in a minute. And after that, I'll just run some code to show you some actual metadata and run the resolver on this very simple example that we had at the beginning. So this might be a little difficult to read from the back. That's always a goodie if you're sitting further up front. So this is how we would model a module like Java Desktop. Here I'm already giving something away. In the OSGi way. So what we see at the top are capabilities of the Java module. So these are resource capabilities in their various namespaces. So if you're not so familiar with requirements and capabilities, they are always belong into a namespace, and the namespaces are defined by the OSGi specs. So you have an identity namespace, that's a very basic one, which is normally not used for resolution, but just as a very basic property of any object to have an identity, in this case, the Java module name and a version. And you can see that we introduce a type which is Java module. So that's something we introduce, it's new. Then we use the OSGi wiring bundle to make it to an OSGi bundle. That's the namespace where we again repeat the name, but with the OSGi namespace. And we also say this is a Java module. So this is a special kind of bundle. And again, we have a version, in this case, it could be empty. So the version could actually be empty. And then the packages that the Java module exports, we provide in the OSGi wiring package namespace, simply as the names of the packages exported, and they have no version. Then we might have provided services. Here you see an example of a media device provider service provided through this service loader namespace. And then you have requirements for a module, and these are mainly requirements to other modules, because that's more or less what Java provides you with. A module can require other modules. And this we model by saying we, by using a filter, as you always do in requirements. So we require something which is, for instance, here the Java base. The name has the name Java base and has the version 10.02 in this case, and is a Java module, and that's the critical new thing. So we say, this is just like a bundle requirement, but we require a special kind of bundle, namely one which has this Java module true attribute. And all OSGi bundles would not have that attribute, so they would not resolve against this. That's what we propose. So hopefully I'm reasonably good in time, because then I could show some code. So I have 3 little projects here. One is sort of the meat of the proposal, which is how to encode a Java module. It's in the JPMS encoder project. In the resource project, that's not so interesting. There we have we implement the OSGi resource API just to have a kind of mock-up to make our test sort of be be complete in itself. And then we have one test, one little test which exercises this little model that we've built. And this is a standard unit test, which I'm going to run, but I'm going to explain what it does before I run it. So we create this mock bundle from the example I showed initially. It's just a bundle which requires a package of name java.awt, and this bundle has the name awt client. So this is the bundle we create. Then we need a resolve context. That's a little OSGi magic that you need to run the OSGi Resolver. The context is an object that the platform usually provides, but that you need to provide to the resolver so that it can ask you for specific providers when it's looking up potential providers for requirements. And the main thing you need to know about this is that we're going to pass it the bundle that we've just artificially created, because this is all metadata manipulation, and we're providing it the list of Java modules. Now, where do we get this list of Java modules from? We create that while we stand up the test as a in the setup method for the JUnit test. And this is something where we run through the modules that the JRE will provide us. For each module, we ask it for its descriptor. That's standard Java API. And this, we use a function, a method that we've written, which will sort of map what Java tells us about the module into the OSGi speak of resources. And that's what this little project does. So we have something called JMod bundles, a class which has this one main method, which is extract resource. And this builds sort of the resource description that you saw as a graphic a couple of minutes ago. So it runs through the module descriptor. It just adds these very basic namespaces, which are based on the module name and the version, if we have it. And then it goes through the exports defined by the JRE, and for each it creates this capability, this OSGi capability, mainly consisting of the package name and a version if we have one, but in Java we don't. And then there is something called opens, which is a special Java module thing where you can open up packages for reflection, but that's already something quite special. And then we look through the requires attributes of the Java module, giving us the bundle requirements. So for each of these, we create a requirement in the bundle namespace where we use the Java module name that we get from the Java API to create the requirement to this special kind of OSGi bundle. And we also model the services, if there are any, which are part of this service loader thing. So I've got this little test example prepared, which is, so this one here. Let me run this one, just one test. There are several ones in the, oops, I don't want to delete anything. I want to run this as a JUnit test. So not surprisingly, it succeeds, but here's the console for it. So here we have our OSGi console, the running one. So you see lots and lots of data. And before I sort of explain the happy end to you, I'll just go back to the beginning of all this, because the first thing the setup does of the test, it just dumps all the modules that Java has told it about. So in this case, there are 60. This is the Java version I'm using. So it's the Java platform I'm using. I haven't tested all of them. Will give me the module name and the version. And from this, I create this resource representation. The identity I mentioned, the services provider, so the base loader, for instance, provides this file system provider service, and then lots and lots and lots of packages that are exported. So if we go back to the happy end, we see that the test, has the output, the result of the resolver, and what the resolver gives you are wirings. So the resolver is given the task, here are my new bundles, here's what I already have, please give me the wirings to turn this into correct configuration. And these are the wirings the resolver is telling me. So the most interesting one for us at this moment is, okay, this is the this bundle requiring AWT, what has it been wired to? And it has a package wiring because the OSGi bundle requests needs a provider for this one package that we've said it requires, which is AWT. And this has been wired to this resource, which is Java Desktop. So I don't know if you knew beforehand, but AWT is implemented in the Java Desktop module. But these are additional new wirings that the resolver had to give us because there are additional modules required for a complete configuration. This is because Java Desktop in turn has requirements. And here we can see which they are. So this is Java Desktop, and these are the wirings that the resolver needed to figure out, which was it needs something called Java Press and it needs something called Java Transfer, and this has been wired to the the appropriate bundle, to Java Press. And this is this is a complete OSGi wiring, giving us containing no OSGi internal wirings, only wirings to the Java platform in this case, because my example was so simple. But you can see that whether it's surprising for you or not, anything requiring AWT would need Java Desktop, which is less surprising, but it also needs data transfer for some reason. It needs Java Press, it needs Java XML, and Java Base, as you always need. Any module would need Java Base. So that's kind of a happy end. We have a way to use the resolver to tell us to reason about the dependencies between OSGi bundles and Java modules. That's sort of the story. So what I think is cool about it is it's actually quite simple. So if we go back to this, it's not that complex. We've actually taken Java modules and added just quite unsurprising OSGi requirements and capabilities to them. And we can use them and we can generate them from the Java runtime. That's what the code showed. So in that we have a complete scenario which allows us to, in one homogeneous step, look at the metadata of Java modules and the OSGi world in one thing, in one place. Okay, questions?
Yeah, I mean, obviously in your test case, you at runtime introspected a set of modules and generated that, but clearly you wouldn't do that all the time. So you probably
we would hope that the layer would
an index offline of all the modules known for Java 10 or Java 11 or Java 12, and then you could use that as part of your analysis resolution step.
Well, the traditional way that OSGi knows about the system package is that they have a hard-coded list, but that's fragile, right? I don't even know if it's the same for the Java I'm using, which is not Oracle, and the Oracle Java. They might be different, and the versions are different. I mean,
right, but the thing that varies at runtime is which modules are present, not what they contain. What they contain is fixed.
Well, in the case that we have third-party modules, it might even not. It might be
true in that case,
but clearly you would want to cache that. You wouldn't want to do it sort of every time. You would hope that at startup time the framework would either lazily or eagerly populate it.
If you're resolving in some remote repository, you wouldn't download the entire remote repository and index it. You would use an index.
Yes, right. That's true.
Other questions? We have a few minutes.
Sorry, I was excited. I didn't listen to the motivation on what's the scope of it. designate classes in different modules, and whether modular JVM can cope with the same isolation that OSGi provides?
So we're not discussing sort of the Java module approach. So we're just taking that for given. And there it's quite restrictive. So for instance, you cannot have two Java modules that provide the same package.
You can, if you have a layer implementation.
Okay, then yes, that's true.
But that's not part of this.
Well, in this simple proof of concept, it's not part, but yes, that's something we would need to discuss. That's true. So layers are not mentioned, so they probably should be mentioned in the specification. That's true. Hmm?
So you're saying this is work in progress. So what is the time frame? I'm not familiar with the spec or the OSGi specification process. So you're saying you're just working on it and putting to the plate. So what when we expect to become part of the standard? So when's the next standard schedule?
Right, I mean, that's for BJ probably to comment on, but we've just rolled out release 7, so this is part of a proposal what could be included in release 8. So
I've been doing OSGi for almost 20 years, as DJ as well. Our average is usually somewhere between 18 months and 2 years. And we're just, and as Udo said, we just wrapped up 7. And this is a brand new RFP. So this is one of the very first RFPs in the process of producing release 8. So, and although we didn't mention it, our requests for proposal are publicly available on GitHub. So you can watch the sausage being made if you want. Okay, so as this gets reviewed in the expert groups, if you're in our expert groups, this I'm sure Todor and Udo will be taking input from the expert group, perhaps adding more requirements, maybe layers
yeah,
will be added.
happy to.
But we're really, in this case, the fact that we've got encode at all is kind of surprising because this is really beginning to begin. Other questions?
A tiny question. You briefly mentioned opens. I was surprised. What use does an OSGi framework make of open stipulations? Is it relevant for OSGi to know that the Java model opens a language?
Well, it's relevant in the sense that the JPMS and the OSGi encapsulate using different mechanisms in Java. OSGi uses type visibility encapsulation. People can't hear. Oh, sorry. The relevance is that it's different mechanisms. OSGi uses type visibility encapsulation via class loaders, and JPMS uses type accessibility encapsulation as you're using JVM accessibility checks. Which is why you can smash everything together in one class loader and still have some encapsulation. So it's important if you want to be able to utilize something a module, even if you can see it, can you touch it? And that's why open is important. Right? You need to know how to model that, to understand if you can really use a thing. It's not enough to be able to see it, you have to have accessibility to it. That's why open is important.
The direction OSGi needs to actively open some models in order to fix stuff, or is it interested in the opens that's already there?
Well, you can't open another module. A module can open itself to you. Right. So in order, so it's not enough that's why if you require a module, when the system is wired together, it'll construct it. Because normally you can't reflectively access the type, even if you can see them. Right. So it is part of the overall story of encapsulation in this world, and that's why it should be modeled in order to do a resolution. Like it's not enough just to be able to see a thing; you have to be able to use a thing. So it's part of the overall story to understand whether or not a thing is available to you for use. And in the case of this RFP, I imagine that there's going to be a requirement that you only express in action. Again, like I said, we're early in the requirements phase. You know, we are discussing, thinking, brainstorming, and nothing is set yet. But this is just the thinking of some of our experts